The first of two sessions for REST sessions. Part one is for implementing and consuming RESTful APIs regardless of platform. Just API developers and client developers. The client developer, mobile apps, obviously iOS, Android, but more as we move forward, it's also going to be applying to our JavaScript like applications. As we start doing more MVC and JavaScript, the way that those apps are going to be consuming web API is going to be very similar, if not exactly the same, as mobile web API. It's not to say that they're going to use the exact same API. If your JavaScript app is for an admin interface, obviously that would probably use a separate set of APIs than like your mobile app for a client, but who's to say? So with that in mind, this is targeted to everybody. It's implementing and consuming RESTful APIs, techniques for API and client developers. So without further ado, we will dive right in. So first topic is, what is REST? And REST is representational state transfer. It's kind of a funny acronym, but the idea behind that is to represent your data and then use that data to transfer state. So what that means, just read off some bullets. So provides access to resources and not logic. So as opposed to your service-oriented architecture, you're providing access to resources that represent your system. Resource can be a single document or complex objects. Obviously you could have a REST interface to literal Word documents. You'd have a REST interface to objects that span any number of database tables. Kind of the whole point is to mask away that data storage, present these resources that make sense to all of your clients. Resources are not a direct map of that data store. It kind of refocuses on client-server development. So in the year 2005, client-server development was all the rage. You wrote your Windows app, communicated to some server somewhere, and it was just, you have these two separate interfaces. And as you get more into web forms, the way MVC works, it sort of melts those two worlds into like one world, and we're trying to work to separate them again so that your server and your client are really two separate applications maintained by like different developers. And finally, the server does not maintain state, so there's no cookies. There are no cookies. I mean, you use headers, it's all just pure HTTP. So why to use REST? It's predictable, regardless of your domain. REST is a principle of how you represent your domain. So if you use these REST principles, it's going to be predictable. It's going to be discoverable via the routing structure and your standard verbs. So instead of calling actions, you use your HTTP verb to say what action you want to take on that resource. It's simple. Once you know the domain, you generally know the system. So as opposed to having to have a lot of conversations about which business logic I'm calling and things of that nature, once everybody's on the same page about domain, it's up to the client to determine what they need to do with that domain. And finally, it incorporates a lot of W3 standards. In and of itself, REST is not a W3 standard and never will be. So with that in mind, it's all about being pragmatic in your use of REST, and in that pragmatism, uses a lot of standards that are just World Wide Web standards. So now we're kind of look at what standard techniques you would use to implement like a RESTful interface. So the first would be data transfer objects to represent resources. It's the concept of masking your database, masking your data store, not making your clients have to worry about all the ins and outs of that data store. It's the concept of designing and using reasonable data transfer objects that go from the server to the client and vice versa. You use routing to locate those resources. Use HTTP verbs that perform actions on those resources. Content negotiation is an important part of this. So, technically REST is really geared towards JSON or XML. Now the whole community has progressed to use JSON and use JSON. People hate XML, and there's good reason for that. However, there's nothing in REST that says that you have to use JSON. So that's where you would use like content type to describe your own body, your own content as the request, and then the server's response, which should respect the header that you say, like, I need JSON, I need XML. Finally, when you make your responses, you should respond with appropriate HTTP status codes. So as an aside, if anybody has anything they want to interject during the presentation, by all means interject, and we'll also, if you're more comfortable waiting until the end, we'll have a little bit of a Q&A at the end. So with any luck, we can get at least a little bit of a discussion going today so we can kind of define the way this will look to us. So data transfer objects. So this is like a really important one. This is your resource. And representing your resource to the world in general, there's a bit of art to that in determining what type of data do my clients need. You have to be able to think one step above your data store to say that this is a resource that via the properties on this resource I can represent logic with that resource. So it really takes it a whole extra level. You would never want to make a client developer have to make a ton of separate calls to all these different resources to put together a reasonable object. So as a server developer, you might think of that as like a SQL view at a basic level to say, I don't need them to make a separate call to the address table to get an address for a customer. Why don't I just include an address object on that customer by default? So, a little bit of work in that regard can go a long ways. Obviously, balancing these data transfer objects with, is my system going to be geared towards hundreds of thousands of users, and hitting a database twice could potentially be a very painful point at which, you're going to start writing your SQL statements that have a lot of selects. You're going to be doing a NoSQL data store. Do you have to do other things in the background to make it faster? Well, the client shouldn't have to worry about that. The client should only worry about your data transfer objects. So no matter what your data store is, as long as those DTOs are staying the same and consistent, your client apps will continue working, and you can do whatever you need to do on the server to make your assistant better.
Kevin, a quick question on that.
Shoot.
Does that make it less modular, though, if you're combining all your different objects together in one super big object?
Right, and that's why I started with a much smaller example of just include the address on the customer. Start small. And oftentimes, that becomes a bit of a conversation. So in and of itself, splitting things into just each resource maps to a database table, and you just have to build your information out of separate requests to different resources. That's always a really good starting point. As the server developer, you can make some really smart guesses as to the extra information somebody might need. And then ultimately, as the API developer, having a conversation with your client to say, well, every time I have to make this call to get notes, every single time. Well, maybe at some point it would be a good idea to include notes on that object. Obviously, the example you say, the whole complex world, you don't want to predict too much ahead of time. That's kind of as the API developer, you're in a bit of that business of predicting what a client needs. So, grain of salt. Does that answer kind of where you're going with that?
There are guidelines when you cut that off, right? After 5 objects, you
absolutely.
stop.
That's why you can never have a real standard around REST. You can have standard ways that you implement it. But there's nothing that says maximum of 3 relations. You know what I mean? But chances are you don't want to have an object has a list of child objects, and each of those child objects also has lists of child objects that have 3 other sub-objects. If you're getting into that level, you really might want to think about, well, why don't I just break this into separate resources? Because ultimately, each of those child objects, you're probably going to have a resource endpoint for that child object in the first place. Which kind of gets to routes. And routing has to do with the location of your resources. So it represents paths to a resource. So we're going to use the example of customers a lot today and tomorrow. So the API/customer route, that would be a route to all the endpoints, all the verbs, anything that you need to do with a given customer. A route can represent the location of a unique resource. You'd be like API customer /1/2/3 to get a customer that as the server developer you would think of as a customer with the ID of 1, 2, or 3. As a client developer, you're not quite as concerned in terms of it being an actual primary key from a database. As the API developer, you set it up so this would represent a unique resource. It doesn't have to be a primary key. Good practice, make it a primary key though. It kind of goes one step ahead of that, or above that, excuse me. Routing constructor can imply relationships. So if you have a customer object and you want to get orders for a customer, that'd be a natural way to describe that relationship is to have a route such that you get to the orders via the customer. That isn't to say that in your server code you need to have this giant object where all customers and orders are all handled in the same class. It all depends on your server framework that allows you to break that up and route things appropriately to your logic. Shoot.
Quick question. So those examples you just had up, API/customer. Customer to me seems like a database table.
Most of the time.
Right, most of the time. But if you have an object like you were just saying, has multiple tables, it's complex in some way. Is there a good naming convention when you have something more complex?
As the API developer, you would name it customer. You would never be like solely focused on this is the way you get at the raw customer data and this is the way you get to my DTO that represents customer data. You would just represent the customer data as you deem necessary, so you would add to that call more and more. And that's where you have to start toying with the idea of like, how performant is this? If I have 100,000 simultaneous requests, it can get expensive to create a complex DTO. And then you really need to get more focused on this explicit data. But by and large, the systems we do here are not geared towards 100,000 simultaneous requests. And if we're at that point, we're typically dealing with a cloud environment that allows you to scale, such that one extra call instead of two instead of one call, it's not a huge difference maker if you're writing reasonable SQL. So, that was in a question as to the routing structure and having customer objects opposed to like customer advanced. You wouldn't have customer advanced, you would just have customer. That said, it's art. If you think it makes more sense to do advanced customer, you can go that direction, but you want to be able to like defend why you made that decision, because ultimately then you have to tell, hey client guys, use this one in this case, use that one in that case, and then you kind of have to own that concept, right? Routing basically represents a versioned API, so we've probably seen this recently, putting V1 in our routes to our APIs, so I think it's very handy. If not an absolute standard, I think that is a good direction to go, to just kick it off with V1 straight away. And ultimately, now, in the rest of the world, you read it everywhere, customers, products, orders. Don't mess with plurals. I think people understand that the customer endpoint is not specifically for a customer, it is for any type of customer object. And that way we don't have to define plurals, i.e. S, as opposed to just an S and things like that. So we discussed DTOs to represent your resources. We're discussing routing to access those resources. And now we get to HTTP verbs. W3 standard, we're going to plan on using all 5 of these verbs. Use get to get one or more resources. You post to create a new resource. You put to update a resource. You patch to partially update a resource. And you delete to delete a resource. So no more endpoints called customer/delete, customer/create a new customer with a bunch of other business logic attached to creating that customer. Let your client decide what they need to be set on that customer so they can do their jobs. Typically, historically here, we've only done get and post. We've used post to represent put, patch, and delete. I imagine we will be doing get, post, put, and delete on a regular basis. Patch is a bit of a trickier thing because you're saying that you're only going to update some subset of properties on a given object. So that could obviously get tricky in JSON serialization. If you don't include a property as the client, I'm like, oh, I'm just going to submit some dictionary. And if the server is set up to interpret that dictionary as a complete object, typically the server will set a bunch of properties to null, or if they were primitives, be like the number 0, which will totally muck up your data. So if you do implement patch, be wise about it. Think in terms of dictionaries, not necessarily complete objects, with the understanding that that dictionary can be any subset or complete set of the properties on that resource. So verbs are kind of split into 2 different types. You have safe methods. Specifically, you only get data, you take no action on data. Whenever you do a get, you should only be getting resources. You should never attach any other logic to that get that would have any change of state on the server. You have this concept of item potency, that any n number of actions will be totally equivalent. So that is your put, patch, and delete. So post will create a new object every single time you post. Put, patch, and delete should have the exact same action on that object that is represented by that unique route. So you're looking at route can represent the location of a unique resource. So if I wanted to put, post, or put, patch, or delete this customer with that ID, I would send the verb to that specific endpoint. Within reason, of course, since delete, once the object is gone, You might get a 404 if you try to delete it a second time. Interesting point about put versus post. So typically put is to update, post is to create. There is a bit of an edge case though to kind of think of in terms of REST. If you think RESTfully, say I have an endpoint API/user/ID/documents or something, right? If I am a user, perhaps I'm just uploading documents to the system. I determine the key to that document. It's like a file name, right? That's how I identify my resource. If I want to put or patch or delete to that resource identifier, if it's the same file name, it's just going to have that same effect, right? So in theory, put could be used to create a new resource at that location. However, in practice, you typically think in terms of primary keys, where clients are not deciding the unique identifier of a resource. But in terms of REST, there's a little wiggle room there still. Content negotiation. So this is to say, I want JSON, I want XML, I'm giving you JSON, or I'm giving you XML. So typically in our web API stuff, we use JSON. It defaults to XML though. So as the client, you need to be aware of the content type header, which says what my body has in it, application JSON. And you also want to be aware of the accept header, which will tell the server to marshal the object into the representation you want, JSON versus XML. The server should respect what the client is asking. Status codes. So this is another key component here. We're going to start using status codes to really represent what happens, what's happening on the server. You're not going to just return. The worst thing in the world is something with the project where even when things failed, we return 200 every time, and if it failed, they just returned the string FALSE. So everybody's wondering, like, why are our web services not working? It's because they're returning 200 OK with the word false. It's very bad. You return at 500 or something if something failed, or 400 if it was up to the client that did something wrong. In any case, your basics are 200 OK. Things went great. 201 created. If you're doing posts, it's nice to send a 201 created to let the client so cared to know that something actually got created. The 300 status codes are for redirection. As an API developer, you generally won't use this too much because it's really up to the client to understand what this status code would mean. So, oh, that's cool. I want to redirect you to here. Well, if you're a browser, the browser handles that redirection. If you're an API client and you're like writing your mobile app to do this, are you really going to be looking at 304 to like automatically redirect your calls to the next place? Probably not. So in practice, we probably won't be using the 300s so much. All right, 400s. These ones are a little more interesting. So this is where the client did something wrong and sent something that they shouldn't have sent, or that the client or that the server cannot understand. So your two basic ones here are 401 unauthorized and 404 not found. 404 not found is kind of what you think. It's not there. There's nothing here. It's not found. Can also be used in security situation. It's explained here. So 401, you're not authorized to access or perform actions on a type of resource. And then in terms of security, the 404 would say the request is not authorized to access a specific resource. So imagine I am user A trying to access user B's information. If I return a 401, I am implicitly telling you that the resource exists, but you don't have access to it. It's more secure to say 404 not found. As yourself, that resource does not exist. 404 not found. So there's also 403 forbidden. Used a little less. Kind of things like file paths, like if I'm trying to access a file path on the server via my API or something like that, it would be like, you are forbidden to access the file system on the server. But technically, really what forbidden means is that the server is not going to tell you why you can't access it, you just can't access it. Kind of not useful in terms of our API clients in development. And ultimately, 500 server errors. The internal server error is 500. Consider returning a stack trace when not in production. If you're in production, do not return stack traces. That is a pretty big security vulnerability. You're telling people what your code looks like. Bad, bad, bad. And then 501 not implemented. It's a good idea to scaffold your API with what you think is the API developer that your clients will need. And as you implement things, replace throwing a 501 with the actual code and say, like, I haven't implemented delete yet. but I plan to. It's helpful to provide the 501 not implemented so that your client developer doesn't have to go track you down and be like, why isn't it developed? The least not working yet. It's because it's not implemented yet. We're planning on it. So it just helps describe your API.
Hey Kevin, just
Go ahead.
quickly, regarding 403, some frameworks use that. They'll use 401 to indicate, you're not an authorized user, but 403 to indicate that you don't have permission for a given resource. So it's not that
Absolutely.
your credentials are wrong or anything like that, but you might not be able to upload a file, and that's typical of Django and Rails.
Absolutely, it really is. Yeah, exactly. That's a really good point. Talking about 403, because in the terms of our API development and our client development, I feel 403 can be a little redundant. However, a lot of systems will use 403 to represent specific information. It's a very good point. So, there's a lot of, these are just a handful of status codes. There's really like 10 different status codes that your typical REST framework can, to utilize, like a 204, I think is content not modified or something like that. Can be useful in certain situations. Is that go ahead, Taylor.
I was just going to add to that. As an API developer, you can always attach a message too for clarification. So you're not stuck with just the status code. You can say you're 403 forbidden and then tell them why if you so.
Exactly, if you wanted to, absolutely. Yeah, so in all of these cases, you can always return additional information to the status code outside of just like the object that would have returned if it was a 200, like everything went good. More information, more better. So now we're going to get into just the standard resource API that we're sort of gearing our development towards. So kind of just building on everything we talked about. If we had a customer resource, this is what our standard API would look like. You'd be able to get to return a list of all customers. You could get to return a customer located at that URI, i.e. return a customer by ID. You can post to create a new customer using the JSON and the request body. It's an important concept. You're posting, you have your headers, and then you have your request body. Your request body is represented by the content type in your headers. It all kind of fits together. And after you post, you should respond with the newly created customer via the response body so that the client stays in sync with the server. That is the idea that, if something for some reason did go wrong, say the server 200 okay, but it's only 200 okay, but maybe something actually went wrong, this can be a really sinister issue to bugs as a client. Never just assume that what you posted or put or patched worked and update your UI with your local model. You should either rely on the object that gets returned to you, or you should follow up with an additional get if the API does not already return that object to you. You want to stay in sync with the server. If you get out of sync, it can be really, really tricky to track down bugs. So put's kind of a similar idea. You update the customer at a given URI, respond with the updated customer. And then patch, you would partially update the customer at the URI, subset or complete set of the different properties, and just like post and put, you respond with the complete updated customer so that so that your client developer UI can respect that information. Finally, the ability to delete a customer at a URI, delete a customer by ID, good to go. Customer isn't there, 404. So does that kind of make sense? Get, post, put, patch, delete. Charlie.
So just to confirm, so in the actual URL, you'll only be ever passing out your unique identifier, right?
That's correct.
And everything else should be in the body.
That's correct. Yeah, exactly. So it separates out the idea of actions. In MVC, you do everything based on actions. In Web API, you can either use actions or you can do attribute routing. Attribute routing is actually a new thing in the Web API 2, which I think came out at the end of 2013, early 2014. And that sort of deprecates in a lot of ways what those route templates are where you're performing actions. So exactly, your routes are extremely consistent and basic for a given endpoint. It's just basically API/customer or API/customer/ the ID. And then from there, it's all based on HTTP verbs. And then in terms of you as an actual developer, the names of your methods could be whatever you want. You name your method supercalifragilistic, and you can name another one expialidocious, and as long as the verbs are decorated properly, it'll all get routed to the right places. So this is obviously the trick with REST, is, what about operations and the concept of a service-oriented architecture? Well, it's not an easy answer. When you do your best to represent operations via resources. And a really good example of that is the idea of expiring a customer. So, on one hand, you could post to an expire action to expire the customer. It's pretty reasonable. Sometimes you still need to represent actions on your endpoints. You know, just to say REST doesn't mean you can't use actions. It's more the idea to set up this framework that you can then build actions on top of. That said, get confused. What if you have the concept of an expiration resource in the system? So am I expiring a customer, or am I performing verbs on an expire resource? Not really clear. You know, an alternative would be to use properties on the object, but then you have to like say for each of my 3 things that are idempotent, or post, which is not, at which you are modifying a resource or creating a new resource, then you have to like look at the existence of those properties and what those properties are set to, which can get a little messy as well. There's no clear answer here. So you just have to use your best judgment. The idea though is to start with resources before you start thinking in terms of actions and operations. So it's not a, you know, it's kind of the way it is. So that's pretty much the end of this. What else can you learn? There's a great API tutorial, RESTAPItutorial.com. Just has a bunch of information. Obvious, good URL. HTTP response caching is something we did not cover here, and will require a lot more thought and focus organizationally before we implement that. But REST, because of these concepts where it's all based on verbs and it's all based on your headers and very basic routing, can make it very easy to just use this concept of HTTP response caching. So you use headers to say like the cache, like how long the cache would live, you know, when it would expire, things of that nature. It's a pretty complex subject, but in theory, it's somewhere we could go so that without writing a single bit of code, if you have a good RESTful framework on your client, and then obviously Web API on .NET is another good RESTful server structure, it is all built to interpret these response cache headers, and then you don't have to do any work. You just pop a couple headers in there, and then the client will automatically know not to go make a call to the server, or if a call does make it to the server in theory might already be like, well, I already have this data on hand, just return the last JSON like body that came for this given request. But it gets really deep, so we're not pushing in that direction just yet. You have to think about like object level security and things like that. Go ahead, Ross.
Yeah, so this isn't my area. So what happens if you don't have that sort of system in place?
Response caching?
Yeah.
Well, right now, we are either manually implementing caching via frameworks like on the mobile devices we have SQLite and things like that. Certainly in FAIR, you're being exposed to a lot of that world, like having databases. Then on the server, are you doing like in-memory representations of your cached results and things like that? It's all highly manual otherwise. There's certainly frameworks in place, especially on the server side, that can assist with that. But kind of the idea is that as the client, especially on Android, which I'm most familiar with, in our retrofit framework, it's like built in. It will respect your cache headers, and it just keeps a file, just a bunch of bytes, and it knows where to look in that file to pull out the response if the way it was cached matches what your request is. So it's just auto magic. It's pretty impressive. Does that kind of answer your question? Cool. Finally, we have this concept of hate OAS or hate OAS, hate. Hypertext, that's the engine of application state. So this is like REST advanced. It's the idea that you can represent resources via hyperlinks in your response bodies. So imagine a case where you are searching, you are doing page results, and you're using gets to do those page results in this case. If I say get and I provide a query string of parameters at the back of the request to say like I need this page and blah blah blah, you could definitely have your DTO include a previous page and next page, and instead of being like here are a bunch of properties you have to go and rework to turn into new JSON requests or something like that, it can just be a link that says the next page is located at API/customer verb get with these like parameters, and the previous page is this one. Really makes sense in terms of like your web development that your HTML could just represent in your pager. They just put those links down there and you're good to go instead of having to do work to build your request. It definitely extends beyond that. There's the idea of like expandable objects. So in terms of your get, you could say like, I need these sub-objects to be expanded automatically. And if I did not request those sub-objects to be expanded automatically, the server could return and say, well, in place of the complete expanded object, here is a link to a resource that represents what that object is. So it can be very powerful, but it requires coordination, that both your API client and your API server developer, both sides have to be able to get on the same page as to what this hypermedia represents. And there aren't a lot of frameworks that just automatically create this for you. It takes a lot of manual work to implement. So it's something that's getting tossed around in like the discussion a lot more again. Came up like 2008, 2009, so it's not a new topic. Finally, if you can solve the problem with join tables, we will buy you beer. Can anybody guess why join tables are a problem? Anybody? Join tables.
Scalability?
That is definitely one thing. If I have to like make a call to a join table every time to get the next object, then I have to make 3 calls instead of 1. So basically, as a client developer, the last thing I want to do is have to deal with a resource called customer address. It's very confusing. The join table is the direct map to your data store, and all of a sudden I have to know your data store. I have to understand what these joins mean to create the data that I need. There is no clear answer on this subject. Because if your data store has these join tables, in a sense, I mean, we did it on Project Drew, where I was kind of providing the join table information to you through the API. It actually worked, but it creates this like level of indirection between like this object's related to that object. Technically, as a client developer, I should just be like, I'm giving you an address, go put it somewhere. I don't care that like the customer address table exists. You could be using NoSQL. There is no customer address table because there are no join tables in NoSQL like type worlds. So, I point this out because A, a lot of smart people have not come up with ubiquitous solutions to this, and B, there are a lot of smart people here, and if we can come up with a good solution to this that we put into practice regularly, it would really help and advance our process. Things that we're doing with the ATP and the Entity API. There's a lot of things that could get solved by just having a consistent way to deal with join tables. So, that's kind of the moral of the story is don't put a resource out there that represents a join table. If you do that, you're kind of doing it wrong. So, so there's your final notes. All right. So thank you for listening. So Q&A. It's a lot of information you've thrown at everybody. I respect that. How are we doing on time, TJ? What time is it?
It is 1:10.
Perfect. So we have 10 minutes. We just have, a bit of a discussion. I mean, this is all sort of prompted because we have a lot of confusion between, so-called 2 ends of the building, which does not exist anymore. Which is a fantastic thing. I think it will really help communication between all the different developers and teams in the building. But this is something that really touches all of us. So, I mean, if anybody has an experience perhaps that might be improved, here we go. But it's all experience based. REST, it's not a standard. It's just a pragmatic approach to designing your web API, and it's really a discussion. It's a discussion you have to have with your team. Well, you don't want to expose a join table. This is a good start to just be like, I have a data store. Here are the resources in my data store. Hey, client, go have at it. And you have to balance that. Do you want your client, what if the client's just hauling ass, just writing tons of code? Works great until you have a lot of data in the system. All of a sudden I'm making 3 and 4 requests at a time when it could be consolidated in 1 request. Well, if I build a whole architecture around having to make 4 requests to build my 1 object, it would have been a good idea maybe to find that DTO ahead of time. Think about that and have that discussion. So, that's sort of the driving point to this discussion. Shoot, Taylor.
Is this going to change much with Web API being absorbed into the MVC framework?
No, it should not. There will still be attribute routing. Attribute routing will not be going away.
And
So,
you can still respond with like a HTTP message instead of an action result or JSON result or something?
so that's a good question. That's going to be definitely covered more in detail tomorrow.
Okay.
I'm definitely focused on the technology that's available to us right now. So, as far as what MVC 6 is providing and when that comes out, how quickly we're going to try and adopt those techniques, that will not change the ability to adhere to the things that we were putting out in today's discussion. That might change what you're doing as a server developer to implement that RESTful API. Well, cheers, guys. Hopefully, less confusion. A little precursor to tomorrow's discussion. Help pages exist in Web API. So, after tomorrow, hopefully every API that's under development, we can get those help pages up, and you can see what your API actually looks like as a client developer. As a server developer, you can do little decorations to that to make it even easier to consume. And yeah, none of this is technology specific, so go have at it. Go make some Google App Engine APIs. Feel free.